future, we will be building many circuits. So now we will be building our first circuit and using this multimeter seen here to measure the voltage of the battery and the resistance of the resistor that we will be using to build our circuit. Here we have two wires. There's a black wire and a red wire. The red wire is positive and the black wire is negative. Let's begin by sketching our electrical circuit. Today we are just going to have a simple circuit with one battery. This is 9 volts. One resistor. This is a 10,000 ohm resistor. And one LED. An LED is simply just a small light bulb. Here you will see two small wires coming off of the light bulb. The longer one is positive and the shorter one is negative. In addition, you will need a few wires such as the ones seen here. How about we sketch our circuit? First, we will have a power source. This is how a power source is represented. The longer line is the positive terminal, and the shorter line is the negative terminal of our battery. Next, we draw a wire with a simple line. This wire leads to our resistor, seen here. The resistor we are using is 10K ohms. And then we have an LED. This is how we represent the small light bulb. Next, we complete our circuit by bringing it back to the original battery. Now we are bringing it back, however, to the negative terminal. This right here is a breadboard. A breadboard, in a way, is an electronic designer's dream. Here we see the numbers 1 through 30. And the letters A through J. A breadboard is great because if we were to put a component, for example, in J5, seen here, and another component at F5, they would automatically be connected. First, let us plug the wire that will be leading to the positive terminal of the battery. I have plugged this one into J3, but you can really start with any place on the breadboard that you want, since this is just the first wire we will be using for our circuit. Next, we need another wire that will lead to the negative terminal. I have chosen -3 as the spot for this wire. We will be connecting these two wires to the battery at the very end of this circuit, just so the battery doesn't end up toppling over our breadboard. Now, let's get to our resistor. As I mentioned before, the resistor to conduct with the wire here must be placed on number 3, but we can place it in any letter that we want as long as it is in the number 3 column. I am placing this into F3. I'm just placing the resistor comfortably. The other side of the resistor is on F12. Next, we have our LED. Similarly, now that our resistor ends at number 12, the LED also has to be placed in the column number 12. So here I am placing the LED into G. Because our LED ends at number 14, we are now connecting a wire from H14, meaning that this side of the LED and this wire will be connected. And let us complete our circuit by bringing this back to the negative terminal or ground. Also, all of these in the negative terminal and these that are in the positive row all conduct together. So now let's place these wires, this one into positive and this one into negative. Okay, so as you can see, our light bulb is now glowing. Yay! If you're doing this along with me, you've probably built your first electronic circuit. Let's switch on our multimeter and measure the voltage through our battery and the resistance of our resistor. I just switched this dial to the mode that says V for volt, as we will now be measuring the voltage from our battery. Attaching the red wire to the positive terminal and the black wire to the negative terminal, we get a variety of readings. As we can see, the maximum voltage reads to be 6.62 volts. As I mentioned before, this is actually a 9-volt battery. I've been using it for a while though, so 6.6 is around what's expected. Let's measure the resistance now. I found that it's more convenient if we actually put the 2 pins into the holes of the breadboard. Let's now change the mode on our multimeter to ohms. This is actually already on kilo ohms, but if it weren't, we could change the mode with this select button. As you can see, we are now getting a reading of 10.02 kilo ohms. This is actually a 10 kilo ohm resistor, so the reading is a bit over, but quite close. This concludes our video. From each Nerdina to all Nerdinas. Adios.